Okay, well, thank you all for coming to class or watching the video. At least you're doing that. Anyway, and thank you to those of you who gave some responses at the midpoint feedback form. They are much appreciated. About 20% of you have responded. So, you know, I mean, this is stuff I'm taking in to, you know, we're trying to make the class as good and useful as it can be for you guys. That's our goal. I mean, that's my goal. And so, you know, whatever feedback you guys have, I appreciate. Getting different opinions about different things. So, you know, some of you guys love data camp and others of you do not like it at all. And so it's going to be hard to make everybody happy, but at least, you know, maybe we can tailor the class accordingly. So anyway, if you haven't filled it out, fill it out, and we'll go. And then, you know, different people have given me good feedback about how to improve lectures. I haven't been able to incorporate it for today's lecture. So today's lecture will be kind of in the style of what I've been doing so far. But, you know, perhaps next week I can start making some changes as well. So all in the hope of being useful and beneficial for you guys, okay? All right, so today we'll continue taking a look at Pandas. Pandas is going to be our main interface for interacting with data within Python, or I guess our main package and tool for interacting data. And again, you know, Pandas are built on top. The data frame is built out of series. Each column is a series, and the series are stored as Numpy arrays. So, you know, that's why we had to kind of cover Numpy and all of this stuff. And then you also needed kind of the groundwork in Python. I think the biggest challenge for me is that I'm trying to cover everything in 10 weeks, which is it's hard. But anyway, let's go ahead and I'll start off by importing Numpy and Pandas. You know, using our standard aliases NP and PD. You know, if you want to follow along, I just pushed this update to GitHub, and it's right here on lecture 0403. And oh, my kernel is not. Hang on, I don't have a kernel running. Give me a second. Let me leave this. Oh, DataCamp wants to know what they can improve. Everybody just wants to be doing their best. Okay, let's see. Is this running? Yes. Kernel ready. Great. So we'll load up Numpy and Pandas. Okay, and I think in our last lecture we talked about indexing and using the loc accessor, the location accessor, and the iloc, the index location accessor. Okay. Another useful thing is this concept of re-indexing. Okay. And so in Pandas, even the columns, so this is a big difference between our data frames and Pandas. Okay, so a lot of data frame stuff in Pandas is very similar to data frame stuff in R, but a key difference is that in Pandas, columns always maintain an index. Okay, in R, when you extract a column, it just becomes a vector, and you no longer know like what those rows were associated with. In Pandas, when you extract a column or whatever, it's going to keep the index. Okay, and the index are basically row names. Okay, and in Pandas we call them indexes, but they're basically row names. Okay, and you have the confusing part about the word index is Python has zero-based like numeric indexing, and you can access values using the numeric index like 0, 1, 2 for the values. But as far as pandas go, the row names are basically indexes, and you can access any of those stuff. Okay. So anyway, I'm going to just create a series here using pandas.series, and I've got these 4 values, and I provided the index DCAB. Okay. So you can kind of specify this, and so 1.4 is associated with D, and you got C, A, and B. Okay. What re-indexing does is it takes whatever pandas object you have, and it takes the data in there, and it has it conform to the new index that you provide. So here I'm going to provide a new index A, B, C, D, E, and it's going to take this and make it conform to this. All right. And so we notice that there's no E value inside original, and so what it's going to do is it's going to fill in a missing value, okay? And it basically just rearranges the values. So A is now at the top with 3.1, then B, which is 4.2, and C, and so on and so forth, okay? So the association between the value and the index is preserved when you re-index, okay? If you don't like that it produces missing values, you can, there's an option for fill value, and here I specified 0 for the fill value, and so it puts in 0. And of course you can put in any value that you want, whatever makes sense for the data that you're dealing with, as far as things like that. Okay. If you've got ordered data or a time series or something, you might want to fill in the values when you re-index. So here I've got the index is going to be 0, 3, and 6. And when I re-index, I'm going to re-index on the range 0 through range 9. Okay, and so that'll go 0 through 8. And if I don't do, let me just cut this out. Okay, if I don't do forward fill, it's going to match up 0, 3, and 6. Okay, blue, purple, and yellow, and it's going to have missing values, nans for everything else. Okay, but I can throw in this option for method as far as re-indexing, and it's going to fill in values, forward fill. And what that does is it takes the value and it pushes each value forward anytime there's a missing until it encounters a new value. So it's going to push this value blue down through 1 and 2, and then once it gets to purple, it's going to push purple forward, and it's going to take yellow and it's going to push that forward as well. So using method, so maybe it's worth throwing here, object 3.reindex range 9 method forward fill. Okay, so this is regular without any optional arguments, lots of missing values. Okay, forward fill pushes the values forward. You can also use bfill, which pulls back values. Okay, so it pulls purple back, it pulls the yellow back, and it's got nothing to pull back for the end, so you still have missing values there. Okay, so that's backfilling, forward filling, backfilling, and this is going to be something that we encounter quite a bit. Okay, you can create. There's something called the date range function in Pandas, and this is very useful for creating ranges of dates. So here we can just say, starting on January 1st, 2010, I want 6 dates with frequency D, and it's going to do January 1st, January 2nd, up through January 6th, okay? And you can specify like 30 of these things, and it will give you 31 will give you the month of January. And then, you could do other options. If we want 6 and period M, okay? What do I have here? January, okay, I guess it gives me the last day of the months here. Okay, that wasn't what I was expecting, but all right. You've got options to create dates here. Okay, so here I'm going to just create. So this has 6 values, and we're going to create a data frame with one column called prices, and those prices will be 101, and then we're going to have a missing value here. We have six values, and so when we do that, our data frame looks like this, okay? And so we're missing a value on the 3rd. And then so you can re-index, and it will kind of push, it will keep these values, and then again, when you re-index, you have the option to use forward fill or backfill. So if I do df2.reindex, I can do date index 2. So this is the new index that I'm using, and I can specify something like method is ffill, and it will push. Why did that not work? Oh, I have to re-index prices. Okay. What am I doing wrong? Bamboozled. Okay. Fill value equals 0. Method equals why is this not? It pushes the 88 forward, but not the 101. And it pulls, okay. All right, I'll have to look up why. Let me look up why the January 3rd isn't filled in. Maybe there's a reason for it. Okay. Okay, well, anyway. The ffill and the bfill do work, but I guess maybe it doesn't apply here. I gotta look up if there's a reason for why this January 3rd isn't filling in. Okay. Anyway, okay. That's a surprise to me. Yeah. Okay, so it works fine. It just doesn't fill in the January 3rd. It apparently looks like this is the supposed behavior. I don't think this is not an error. It's just, I guess in my mind it worked differently, but this is the how it works. Okay. Reindex and .loc behave the same if you don't specify any indices that are missing. Okay. So for example, okay, here is a data frame where the indices are A, B, C, and D, and if I say or it's D, C, A, and B, and if I re-index with A, B, C, D, it just rearranges those values, okay? And using the dataframe.loc accessor gives me the same thing, okay? Just keep in mind that this is something that might trip you up, is that .loc uses square brackets, whereas reindex is a function or a method, and so it uses curved brackets or parentheses, okay? So the .loc and the .iloc are accessors, and so they use square brackets. So just be mindful of that, okay? But anyway, these two things, because every value I'm specifying in reindex and specifying in location are exist in the original data frame, they work the same, okay? But if I reindex and I specify something like E here, which does not exist in the original, reindex will produce a nan value, okay? But using .loc and specifying e gives, well, right now it works, but it gives us something called a future warning, which says your code is going to break pretty soon, okay? So right now in the current iteration of Pandas, it does this because you know, they're constantly making updates, and then somebody says, you know what, we should distinguish these two or something. And so .loc, using the .loc accessor, gives us a warning now, which will turn into an error at a future iteration. So, so anyway, if you're going to specify new values in an index with missing things, you got to use reindex, not the location accessor. The loc accessor is made for finding things that exist. Okay. We have, you can drop rows and columns, okay, and this just fully gets rid of them and stuff. So here, here's a data frame. Row indexes are A, B, C lowercase, and then the column names, or even the column index, are capitals A, B, C, and D, okay, and these are just the integers 0 through 11. You use df.drop, okay? df.drop just drops those things, and so in this case, I'm going to drop columns B and C. By default, if you don't specify anything else, I should probably put this up top. By default, so here I do df.drop, little a, little c, it's going to drop the row A and drop the row C, and we get row B, okay, 4, 5, 6, 7, okay? And that's by default. If you don't specify anything, it'll drop rows, or it'll at least search for these things in the rows. Like if I do A and C, it gives me a key error because it says I didn't find these in the rows because they don't exist. I only have lowercase a, b, and c, and I don't have a capital A or a capital C. So, so it'll give you a key error, okay? Drop columns if you want to get rid of columns B and C, but you want to get rid of the columns, you say axis equals 1, and that'll give you, that'll do the columns. Axis 0 is rows, axis 1 is columns, because that's how we count our axes, right? We go rows, then columns, but we have zero-based indexing, so axis 0 is the rows, and axis 1 is the columns. So this gets rid of columns B and C. Okay, and df remains unchanged. Whenever you use df.drop, it produces a copy, unlike list, you know, in a drop or something, where the lists are mutable. This behavior is different. You do have an optional argument. If you wanted to modify the data frame itself and not produce a copy, you can use argument in place equals true, and that actually modifies the data frame. Okay. All right. Okay. Data alignment. This is I think this is an awesome feature of Pandas. Okay. So here I've got I'm going to create two series. I've got S1 and S2. S1 has indexes A, C, D, and E. There's no B in series S1, series 1. And then series 2 also doesn't have a B and also doesn't have a D. Okay, so we have A, C, E, F, G. Okay, so if I say do S1 plus S2, what it's going to do is it's going to take the indexes, find the union of the index, okay, and then it's going to return, basically it's going to do S1 plus S2 for every value that it finds, okay? And if in the union of the indexes, if it doesn't find it, you know, it's going to fill in a missing value, and And so we get this, okay? So returns a new series where the indexes are the union of the indexes of S1 and S2, okay? And then, so there's no B, right? Because B doesn't exist in either S1 or S2. And then D gets a missing value because S2 doesn't have index D. So it says when we add those two together, I don't know what to do, and it gives us a missing value, okay? And then we have missing values for F and G because series 1 doesn't have F and G. So we get that, okay? So it aligns up the things based on the index names and does the calculation appropriately, right? So 7.3 and negative 2.1, and then, you know, E is 1.5 and negative 1.5, and we get 0.0. So that's good. I think. Okay, it does element wise, but it's going to line it up on the indexes first. Okay, which is fairly different from like R. Okay, in R, if you extract a column and another column, and you say add these two together, it's just going to go element wise, and you know, even if the row names were different and they pertain to different things, it's just gonna treat them all the same and combine them. Okay, in Pandas, the index is very key in kind of identifying all of these things. Okay, similar stuff with data frames. Okay, so here we've got a data frame with Ohio, Texas, Colorado as the rows and columns B, C, and D. In data frame 2, we've got columns B, D, and E, so no C, and we added E. And then the only rows that exist in both are Ohio and Texas, and DF2 has Utah and Oregon, okay? And then so when we add these two together, it's going to return a data frame with the union of the rows and the union of the columns. Okay, so our returned data frame is going to have B, C, D, and E, and then the data frame will have rows Utah, Ohio, Texas, Oregon, and Colorado. Okay, and then it's gonna do give us nans for anything that it can't find. Okay, so and then also by default it arranges the rows kind of in alphabetical. Okay, so again, you know, it makes sense that Colorado is going to get all nans because it only exists in one thing. And so the only thing that doesn't have missing is going to be Ohio and Texas for columns B and D, because those are the only things that exist in both data frames when we align them as far as rows and columns. Okay, you know, you might say, well, this is not what I wanted. So you can do the same thing, df1 plus df2, by using the add method. Okay, so we're going to do df1 add df2, okay, and you would add df2 to df1, and in this case we can specify that the fill value should be 0, and basically if it can't find the value, it's going to put in 0 rather than nan for missing. Okay, and so in this case it fills everything in. So Colorado B, you know, in the original data set was 6. So Colorado BCD is 6, 7, 8. There's no Colorado values in DF2. So the result of add with fill value 0 is going to be 6, 7, 8. Okay? Because Colorado E does not exist in either DF1 nor DF2, that one gets a missing. Okay? So this one will get a missing because it doesn't exist in, there's no Colorado E anywhere in DF1 or DF2. Okay, but it you know, puts in 0 for everything else, and it adds this. And then we got other arithmetic operations: dot add, dot sub, for subtract, multiply, divide, and floor division. Okay. And I think there's also power, any of these things. Okay. filling all of that stuff in. All right. We're going a little bit faster than I had planned. Okay. Let's talk about getting kind of summary stats of a data frame. Okay. Maybe. All right. Well, okay. So here I've got two columns. I've got column 1, column 2, and then the index goes A, B, C, D, E, F, G. And I've got 1.56 missing, 1.546 and missing. And then as far as 2 goes, I got minus 4.5 missing, minus 1.50, minus 4.5, and 4. Okay. All right. You can just do df.sum. All right. And for pandas, the sum will default to doing column sums. Default behavior skips missing values, and default behavior returns column sums. Okay, I should say default behavior sums across index 0, meaning sums the rows. Okay, so you can also df.sum axis equals 1. I should say axis 0. Okay, and then axis 1 will sum across the rows. Okay, and we get this. Okay, and it defaults to I guess zeroing out the missing, or skipping those. All right, so that's what we have there. Across axis 1 will sum across the columns and give row sums. Okay. You can specify skip NA, which means don't skip the missing values, and that's going to return NA missing if any of the values are missing. Okay, and then likewise we have a bunch of these other kind of aggregate summary functions. So df mean will do column means. Okay, and then I'll just do one more of these. Df mean axis equals 1 will give you row means as well. Okay, ID xmin will tell you which row has the minimum value. Okay, so if we look back at the original column, we want to know which row has the smallest value for column 1 and what row is that. So there's a tie in row A and row D for the smallest value of 1.5, and so it's going to give you back the first one. So it's going to give us, it'll tell us row A, or index A, has the minimum value. And then for 2, we've got the smallest value is negative 4.5, which exists in row B and F, and so it'll give us back B. Okay. Okay, so that's IDX min. There's also IDX max if there's multiple ones. Okay. You can ask for unique values within a column. All right, so the unique values that appear in column 1 are 1.5, 6, missing, and 4. Okay, and that's what we get: 1.5, 6, missing, and 4. All right, and they show up in the order that they're observed, as far as what exists in the data set. If you want to know how many unique values, it doesn't count the missing, and so it's going to say you got 1.5, 6, and 4. That's 3 unique values. All right, and then you can also do dot value counts. So notice that these I'm applying all to the series. So I'm doing df.1 for extract out column 1, okay? So if you extract out column 1, apply the unique function, which will give you a set of unique values. Number of unique will give you, the value, how many unique values have. And value counts is going to return a new series, okay? And it's kind of like a table of frequency. It's like a frequency table, except it's a new series. And here, the index of the new series is the value that it tallied up. And the values are the frequencies. So it's going to say the value 6.0 showed up twice, 1.5 showed up twice, and 4.0 showed up once. Okay, so this is going to return a new series of counts. Okay, and then there's other methods that we can apply to the series. All right, you can check to see if a column has values in a kind of a set that you provide, or in this case, a list that I'm providing. So I'm asking which rows or of index of column 1, series 1, has values that are in the set 1.5 and 4.0. Okay, so if we go back to the original data set, we're just looking at column 1 and which ones are in 1.0 and 1.5 and 4.0. It's going to tell me row A, row D, and row E. Okay, and so what it will return is a Boolean series. Okay, and it's going to say true for A, D, and E, and then it's false for the other rows as well, right? And so now that I've got a Boolean series, I can use the Boolean series as a mask for the using the .loc accessor, right? So if you want to kind of filter just down to the rows with particular values or that meet some kind of condition or whatever, you can use that like this, right? So I can say give me back a data frame with the location accessor such that series 1 has values that are in the set 1.5 and 4.0, right? And so we get the subset of data, which has just rows A, D, and E, and these values are 1.5 and 4.0. Okay, so these are all, I feel like these are very useful for when you're doing kind of data manipulation work, right? When you're trying to work with your Pandas stuff, okay? Here, I have a suggestion. So some of you guys were asking, on data camp, I can type in the thing, but I don't feel like I'm like learning it and stuff, okay? And I understand that, okay? One thing I would suggest is, go through, either one of these notebooks or another one, and just kind of make a little paper of the little tasks that you can do, right? So one will be like filter based on column values, right? And just make little tasks, write down the paper and say okay, I want to tally up the values. I want to figure out how many unique elements I have, or something like that. Just write little tasks down, and then close the notebook, and then almost like they're not flashcards because you got to type your command out, but just pull up one of these tasks and see can I do this, right? And if you can't do it, just go on Google and look it up, and then or look back in the notebook, and then and it's just this kind of you have to practice it, right? And so just kind of try it out and say oh yeah, how do I count the number of unique values in a column, right? And maybe you forget and unique, right? it's very common. Like I have to constantly Google stuff, and it's only like after Googling it like the 7th time, I'm like, oh, now it's starting to sink in. Okay, this is just, I feel like you've probably learned R the same way, in that, you know, you were given a homework assignment or something, and you were just like, how do I do this? And you just have to constantly Google these things. You can kind of give yourself training by like listing out tasks that you want to achieve, and then forcing yourself to practice these things over repeatedly. Okay, so all right, let's talk about filtering out missing values. Okay, so here's our original data frame. We've got a bunch of missing values here, and so if you do drop NA, there's df.drop_NA. It's going to return a new data frame, and it just gets rid of any row that has missing values, right? So A has something missing. B, D, E, and F don't have anything missing, but A, C, and G each have missing values, so they get dropped, and we get just things that don't have things. Okay, if you use drop NA, how equals all, and I always forget. I know there's like this ability, but I don't know, the keyword how I can't remember, so I'm always Googling this. And this says only drop the row if the entire row is completely NA, right? Okay, and it'll do that. I'm pretty sure you can also specify on the axes, okay? So if I say axis 1, then only if the column is entirely missing will it drop, okay? But anyway, so this only gets rid of row C, because that's the only one that has missing in both. Okay, and then the series, okay, also has a not null method. Okay, if I just show you not null, this will tell you as far as this one, which ones are not null. Okay, which is true for everything except rows A and C. And so you can just subset the data frame based on one of the columns. So if you only care about missing values in one of the columns, you can say, let's look at column 2, and I want just the ones that are not null there. Okay, and then you'll get just the ones that are not null in column 2. Okay, and then as far as, so it's a common desire to fill in missing values, okay? And so you got drop NAs, and then you've got fill NAs, okay? So fill NA, you can just give a number, and it will put in that number wherever it has missing. So, you know, fill NA is 0, that's fine. So that does that. If you want to use different values for each column, okay, you can give it a dictionary. All right, so oftentimes, you know, you'll forget what it is, but you give it a dictionary. And so for column 1, I want to fill in the missing values with 1,000. For column 2, I want to fill the missing values with 100, and you can do that. Okay, so column 1 gets 1,000 for the missing values and 100 for 0 for column 2. And then just like with re-indexing, you can do ffill or bfill, and it will backfill the values, okay, from the previous thing, or forward fill. So then you got missing up there, but then it pushes these values forward, okay. So these are options: backfill and forward fill. And then probably a most common desire or operation is you want to fill in missing values with the column mean, okay? And so, you know, df.mean provides, it will basically just calculate, give us a series with index, with the values of the means associated with this, okay? And so this is similar to passing the dictionary in for fill NA here, okay? okay? Because a series is not a dictionary, but because the values are associated with an index, you can do this, and it will fill in that value 3.8 for the missing values in column 1, and negative 1.3 for the missing values in column 2. Okay, and so so this is kind of just filling in the column mean there.
Can you fill it for row means as well?
Yeah. So you would do dfna axis equals 1. Okay. Oh, geez. Oh, okay. I have to do df mean axis equals 1, and then df fill na axis equals 1. Oh man, it's not working. Okay. Can only fill with dictionaries and series column. Oh, by column. Okay, never mind. Never mind. I thought for sure we could do this. I was wrong. Axis equals 1. Wait. All right, so we have that. And I guess we can't do that. Well, there's always a workaround. So what would we do if we want to do this? Let me see. All right. Let me just try this. Okay, so I would probably do df.transpose, and then I would do df.transpose.fillNA, and I would do df.transpose.mean as the thing I want to do. Okay, and there we go. And then we would transpose this back. Okay, and now our life is complete. So, okay, so you can do it. It just requires a little bit of creative energy, right? Okay, so fill okay, so apparently I'll write this. Apparently you can only fill missing values with column means, or fill with dictionaries and series over a column. So we have to do some transpose magic. Okay, but it works. Okay. All right, and then oh, I don't know where the other stuff went. Okay, and then okay, so just taking a look at our data frame again, you have this option duplicated, not option, this method duplicated, and it's going to see, are any of these rows duplicated? Okay, and we see that row B has 6.0 and minus 4.5, and row F also has 6.0 and minus 4.5. So if Pandas eyes, those rows are duplicated, and so F gets a duplicate flag. Okay, so the first time it encounters it, so 6 and minus 4.5, these are not duplicates. Okay, or this is not flagged as a duplicate. Okay, only the F is, because when this appears for the first time, it's not a duplicate of something it's seen before. But the second time it appears, then it gets flagged as a duplicate, and so therefore you can subset based on this. Okay, and if you use the tilde, we'll say this will be like not the duplicates, and then will only give you back the one that's duplicated. Okay, so this is gets rid of the duplicated row. You can also apply duplicated to a single column. So I can do df.1.duplicated. Okay, and in this case, if we look at the original value, we got 1.56 missing. Okay, this is going to get flagged as a duplicate, D, and then E is not, but F is duplicated and G. So we get D, F, and G as duplicated, and you can subset based on that or whatever. Okay, so whenever you have a Boolean series, you can use that to then mask or filter out particular rows. Okay, yeah, these are all, I think, handy in as far as selecting the pertinent informations there. Okay, we'll take a break here, or not break, but we'll end here, and we'll see you guys on Monday. Have a good weekend, and yeah, all right, we'll see you then.